Let's talk about chemical equations. So here's how you can use this video. Throughout the video, there's going to be slides that have green text or green text highlighted green. If you're using this to take a notebook, that's what you should write in your notebook. There's also going to be blue text. These are questions for you to consider or questions for you to answer. Now, throughout this video, there's going to be two codes. One is going to be a visual code that will show up on the screen, and the other will be a verbal code said by myself. They can happen in any order, and they're just three randomly generated numbers. So pay attention. All right, let's get started. So chemical equations, right? A chemical equation is a written representation of the process that occurs in a chemical reaction. So think of it as like a recipe. Like if I'm making a peanut butter and jelly sandwich, I need peanut butter, I need jelly, I need bread. Well, then I'm going to make the peanut butter and jelly sandwich. So if we're looking at a chemical equation, the reactants are the starting materials, and they're written on the left-hand side of the equation. The products are the end results, and they're written on the right-hand side of the equation. So if we look at this equation over here, and I like this one, and you might want to write this down. Like if you're using this to take a notebook, you might want to put this in your notebook. But it's labeled the coefficients, the reactants, the products. You can see here, I know it's an equation, but it does not have an equal sign. It's a reaction arrows. And there are different types of reaction arrows, but we can save that for later. But yeah, reaction arrow, reactants are on the left, the products are on the right. And you can see in this one, I didn't write it down, but most of the time, the state of matter is written after each molecule. So you can see here, there's like solids, liquids, gases, then the aqueous, something that's dissolved in water. So this tells you like everything you need about those recipes. Now, this is just the zoomed out version, right? If we zoom in even further, the subscripts and the coefficients, those are the numbers that you see in the the equations, right? Now, subscripts show how many atoms of an element are in a molecule. So if we're looking at H2O, water, right? So the subscripts, well, I've got the 2 is that lowercase, or sorry, 2 hydrogens, 1 oxygen, right? Now with subscripts, you do not write the 1, right? The 1 is just implied, right? So that oxygen, it does not have a subscript there, but it's just a 1. I've got 1 oxygen. At this time, I'll go ahead and give you that verbal code. The verbal code is 798. Now, coefficients show how many molecules there are. So if we're looking at this, 3H2O. So here's the little diagram off to the right here, 3H2O, right? So that means I've got 3 water molecules, right? Now, if I were to do this and I wanted to find out, well, how many hydrogen atoms I have, how many oxygen atoms I have, you just multiply the coefficient times the subscript. So if I was looking at those hydrogens, well, it's 3, that coefficient times the subscript, which is 2, that'll get you 6. And you can see I've written out, or I've drawn out the 3 water molecules, and you can count that out, 1, 2, 3, 4, 5, 6. If I were to ask the oxygen, well, that's 3 times 1, that's 3 oxygen atoms. So that's how you can count the total number of those elements in each molecule, right? You multiply the coefficient by the subscript. So one definition that we need to talk about are diatomics, right? A diatomic element is a molecule composed of 2 of the same atoms. So there's only 7 of them. And they call them diatomics because they appear in pairs. So you'll see these chemical formulas, right? And I just want you to be aware because you might hear like the oxygen molecule. And you're thinking, well, oxygen isn't a molecule, it's an element. Well, no, if it's an oxygen molecule, it's O2. The most commons that you're going to see, at least for this unit, you're going to see like the oxygens, the hydrogens, sometimes like the chlorines, fluorines, but just know that there are 7 that do this, right? So there's a mnemonic device to remember it, like Hofbrinkel, right? But those are the only 7 that do it. But it's just good to know, just in case you get confused, like, oh, why are they saying the hydrogen molecule? No, it just means it's a diatomic element. So let's talk about the law of conservation of mass. It states that in a chemical reaction, matter cannot be created or destroyed, right? So atoms do not change their identity. So a carbon atom can't become an iron atom. Now there must be the same number of each type of atom on each side of that chemical equation. And that's why we balance the equation. So let's just take a look at this chemical equation up here, right? I'll cover up the digital balancers now. But you can see here on the left side, this is a combustion reaction. I've got methane reacting with oxygen to produce carbon dioxide and water. And you can see, well, I've got one carbon. This dark gray one, I've got one carbon on the reactants, one carbon in the product. The oxygens, I've got 4 oxygens in the reactants, 4 oxygens in the product, and then I've got 4 hydrogens in the reactant, 4 hydrogens in the product. Now, if I were to mass these out, I was put this reaction on a digital balance, right? It's completely sealed. If I started with 80 grams, I have to end with 80 grams. I have the same amount, right? All I'm doing is I'm rearranging these atoms. Like, think of it like a recipe, right? That's all you're doing. You're just rearranging it. Now, before we start to balance chemical equations, right, let's just go over an example, just a quick analogy here. How many packages of hot dogs and hot dog buns must be purchased in order to not have any left over, right? So if you're looking at this, hot dogs come in packs of 10, buns come in packs of 8. So in order to find out how many packs of each to buy, you will need to find the least common multiple of 8 and 10, the smallest number that is divisible by both. So if we're looking at this, and I'm just going to fill this out real quick here, right? So if I come in here, right, the least common multiple, there's different ways to do this, but I'm just going to count them out, right? So hot dogs, well, I got 10, 20, 30, 40. Okay, now let's go by 8s here. So 8, 16, 24, 32. Okay, now I'm at 40, right? So that's the least common multiple of 8 and 10. So now if we're balancing this out, I don't want any hot dogs or hot dog buns left over, and I can't go in, I can't just be like, well, I don't want 2 of the hot dogs. You can't take them out of the package. You have to buy whole packages of hot dogs or buns, right? You can't just take them out. You have to buy them at the grocery store in these packages. So how many packs of 10 hot dogs are needed to get to 40 hot dogs? So if I'm balancing this equation here, right, I'm going to need 4 packages of 10 hot dogs, and I'm going to need 5 packages of 8 hot dog buns, and that'll allow me to make 40 hot dogs with buns without any left over. But I had to purchase those whole packages together, right? So with that in mind, now let's talk about how to actually balance those chemical equations. So these are the steps here, and these are a rough outline to balance chemical equations. So what I mean by that is these rules won't necessarily apply to all of them, but these are just great steps to help us. So count the number of atoms in each element on both sides, and we're going to make a simple list. I like to make a table of each element in their reaction. Now balance one element at a time using those coefficients. You do not touch the subscripts. Just like if you're in the grocery store, you can't say, I don't need these 2 hot dogs and take them out of the package. You have to balance using the coefficients, not the subscripts, right? And here's a good rule to start with. Start with the elements that appear in only one compound on each side. This might not be the best strategy for some, but this is a great place to start. Now, I like to say leave hydrogen and oxygen for last, because a lot of the times those come in diatomic elements, and it's going to be easy to affect those without affecting anything else. Sometimes you're not going to have hydrogen and oxygen in the reaction. Sometimes it might make sense to balance one of them first, right? But this is just a good general rule to help us out. And then check your work. Do this with all of the problems, right? Count all the atoms of each element, both sides again, make sure they're equal. And then this one might not apply to all of them, but simplify coefficients if possible. You want it to be as simplified as possible. So that means if they're all divisible by 2, if they're all even, just divide by 2. You want to have the lowest number of coefficients to balance on each side. So I'm going to do a couple problems just to help you out off to the right here, right? So you can see there's the balanced chemical equation up top, but I'm going to do just a couple of these. So this is carbon reacts with oxygen, forming carbon monoxide. So first I'm going to just write down the elements that I have here, carbon and oxygen, and then my reactants, I'm first just going to assume I have 1, right? I just have 1, right? These coefficients are blank. Right here I've got 2. Okay, I've got 1 carbon here. I got 2. So you can see here, oh, nope, sorry. That's a 1, right? My fault, right? So you can see here I'm not balanced, right? I'm not balanced because I've got, well, my carbons are great, but my oxygens are not. So what I need to do is, this is one where it makes sense to start with the oxygen. There's only two elements here. So I'm going to put a 2 here, right? So that means that affects my carbon and the oxygen, right? Remember, we do not write the subscript of 1, it's just implied. So 2 times 1, well, now I've got 2 carbons, okay, and I've got 2 oxygens here. I'll just scratch that out and put 2 here, 2 here. There we go, right? So now, well, my oxygens are balanced, so that's great. I can put a 1 there. Now I've got, even though we don't technically write the coefficients, it's just easier when I'm filling in the blanks here. Then I go in here and I need to have 2 carbons, and that should balance it out, right? Yeah. So this is balanced. All I did was I changed those coefficients, and now I've got the same number of carbons and oxygens on both sides of the chemical equation. It's the law of conservation of mass. Now let's take a look at the next one down here, right? So this is a combustion reaction. So I have 3 different elements: carbon, hydrogen, oxygen. So now I'm just going to start by counting them. I'm just going to assume the coefficients are 1. So I've got 2 carbons, all right? I've got 1 carbon here. I'll write them off to the left, so I'm going to change them. Let's see, I got 4 hydrogens here, and I've got 2 hydrogens here, and I've got 2 oxygens, and I've got 3 oxygens here. Okay, so a little tricky because I've got oxygen in carbon dioxide and that water molecule. So that's why I say, hey, save oxygen for last, because notice I've got oxygen as this diatomic element. So first what I'm going to do is I'm going to start with carbon, because it's 1 and on both sides of my equation, right? So I've got carbon here and I've got carbon here. So what I'm going to do is, well, to balance it, I need to put a 2 here, right? So now that changes my carbons and my oxygens, right? So I put a 2 here. All right, so I'm going to put, I've got 2 carbons, but that also changes my oxygen, because 2 times 2 is 4. Then I have a 5th oxygen here, right? So I've got 5 oxygens. Okay, good. Now I'm going to do my hydrogens, right? Because my hydrogens aren't balanced. So let's see here. I've got 4 on this side, right, on my reactants, and I've got 2, so I'm going to put a 2 here. So this changes my great, my hydrogens are balanced, so I put a 4 here, but this also changes my oxygens, right? So now, well, I've got 6 oxygens in my product, right? So it affected both of them, right? And this is going to be a 1 here, right? So now, and it works out because now that oxygens are even, all I have to do is I just save my oxygens for last, because it's a diatomic element. I can put a 3 here, and now 3 times 2 is 6. So all of these, I'm just going to put an equal sign there. It's an equal sign. So that is a way, that's how you balance chemical equations. You just follow these steps. So here are some practice problems that I can give you. Some of them, right, some of these are pretty, some of them are fairly simple, right, just balancing these chemical equations, right. Some of them only have 2 elements, some of them have 3. Didn't want to make them much harder than that, right? But if you want to, you can pause, you can practice, you can practice balancing these chemical equations. So just as a final thought, remember, there's too much unknown in the universe to take a break from learning. Get out there and question everything.